You're finally drifting off. Your body is heavy. Your thoughts are starting to dissolve into something looser, less linear. And then, without warning, your whole body violently jolts, like you just tripped or fell off something that wasn't there. Your eyes snap open. Your heart is pounding. Nobody touched you. Nothing happened. So, what did your body just react to? Most people assume they were dreaming about falling, and the dream caused the jerk. That's backwards. The jerk usually happens before any dream forms, in the narrow window where you're not quite awake and not quite asleep. Whatever triggered it, it wasn't a dream. It was something your nervous system did on its own. This is called a hypnic jerk, sometimes a sleep start, and it is extremely common. A 2016 study published in the journal Sleep Medicine estimated that somewhere between 60 and 70% of people experience them, and researchers suspect the real number is even higher because most hypnic jerks are small enough that you never wake up or remember them at all. The ones you actually notice are just the biggest ones breaking through. Scientifically, a hypnic jerk belongs to a category of movement called myoclonus, a brief, involuntary muscle contraction. It's the same basic category hiccups belong to. Your diaphragm contracting on its own is myoclonus. Your whole body jolting as you fall asleep is myoclonus too, just a different muscle group, firing once at a very specific moment. This isn't some newly discovered quirk either. Physicians have been documenting it for well over a century. In 1890, the American neurologist Silas Weir Mitchell described patients whose sleep was being disrupted by these same violent jerks, one of the earliest medical records of the phenomenon on file. That moment is the key to understanding what's actually happening. Falling asleep isn't a switch flipping from on to off. It's a handover. Deep in your brainstem, there's a network called the reticular activating system, whose job is to keep you alert and awake. As you drift off, control passes from that alertness network to a separate set of circuits working to shut it down and usher in sleep. And as that handover happens, the steady, low-level tension your muscles carry all day, tension you're not even aware of, starts to drain away. Your muscle tone drops, fast, heading toward the near paralysis your body enters during deep sleep. Somewhere in that fast, imperfect handover, signals get crossed. And that's where the most famous explanation for hypnic jerks comes in, an idea you've probably already heard in some form. The theory goes like this. Our primate ancestors slept in trees. Falling asleep in a tree is dangerous because a fully relaxed body can slip and fall. So the theory suggests early primates evolved a safeguard, a jolt that fires the instant muscle tone drops too fast, snapping the body back to alertness just in time to grab a branch before falling. Under this theory, when you jerk awake tonight, some ancient part of your brain briefly mistook the feeling of your muscles relaxing for the feeling of falling out of a tree. It's a vivid story. It's also, as it turns out, one science can't actually back up. There is no direct evidence for it. And evolutionary biologists have a specific name for the trap this kind of explanation falls into. In 1979, Stephen Jay Gould and Richard Lewontin published an influential paper in the Proceedings of the Royal Society B, arguing that not every trait is an adaptation shaped by natural selection. Some are just incidental byproducts of how the underlying machinery happens to be built, side effects rather than designed features. They called these byproducts spandrels, and the falling tree explanation for hypnic jerks looks a lot like one. It's a plausible story attached to a real phenomenon after the fact, not a story built from actual evidence. There's an even more direct problem with the tree theory. Cats jerk at sleep onset. So do dogs. Neither species has any evolutionary history of sleeping in trees, under any version of this theory. If a species with zero arboreal ancestry twitches at the exact same moment in the sleep cycle that we do, the twitch probably isn't a leftover tree survival reflex at all. It's more likely just noise, an artifact of an imperfect handover between two competing brain systems. The same way a hiccup isn't an adaptation, just your diaphragm briefly misfiring. So if it's not really about falling, what is actually going on? The honest answer is that nobody fully knows yet, and that itself is worth sitting with for a second. This is something happening inside almost every human body, most nights, and the actual mechanism, why this particular signal gets crossed in this particular way, is still unresolved science. What researchers do know is how it changes across a life. Hypnic jerks are far more frequent in childhood. Children between roughly 8 and 12 years old experience them 4 to 7 times an hour while falling asleep, most too small to ever notice. By the time someone reaches their 60s, 70s, or 80s, that rate drops to just 1 or 2 times an hour. Something about the developing, still tuning nervous system of a child produces far more of these misfires than the more settled nervous system of an older adult. And nobody has fully explained that pattern either. Certain things make hypnic jerks more likely on any given night. Stress and anxiety are consistently linked to more frequent jerks, and so is caffeine, especially late in the day. Sleep deprivation seems to matter just as much, on its own. When you're seriously overtired, your body tends to rush through the normal stages of falling asleep instead of easing through them. And that rushed, compressed transition appears to raise the odds of a misfire somewhere along the way. The connecting thread across all of these triggers seems to be arousal. A nervous system that's still running hot, still primed for alertness, has a harder time handing control over cleanly to the sleep system. And a rockier handover means a higher chance that something crosses along the way. Which brings us back to that moment tonight, right before you fall asleep. Every single night, your brain performs something like a live systems check on its own way out. 2 competing networks trade control of your body in the dark, and for one brief, fast moment, that trade doesn't go perfectly clean. Something crosses. A signal meant for one system reaches another. Your whole body reacts to an event that never happened. Maybe there's no ancient tree, no falling branch, no long-dead evolutionary threat hiding behind it at all. Maybe it's simpler and stranger than that. Every night, without asking your permission, your brain hands the controls of your body to another system entirely. And for one fraction of a second, you feel the handover happen.